Hello, and welcome to Chapter 10 of Python for Informatics, the chapter on tuples. I'm Charles Severance. I'm your lecturer, and I'm the author of the textbook. As always, this material is copyright Creative Commons attribution, including the video lectures, the slides, and the book. So, tuples are the third kind of collection that we've talked about. We've talked about lists, we've talked about dictionaries, and in the dictionary lecture we kind of alluded to tuples. We don't have to talk too much about tuples. We're really shortening the lecture by telling you that they're a lot like lists. They're a non-changeable list, and the syntax of them is pretty much the same as a list, except that we use parentheses instead of square brackets. Okay, and so like here is a three-tuple with three items in it: Glenn, Sally, and Joseph. They are numbered 0, 0, 1, and 2, so the second thing is 1. So x sub 2 is indeed Joseph. We can pass them in as sequences to things like max or min or sum. And so the maximum of 192 is 9. And we can loop through them. So here is y, it's a tuple. It's 192. And iteration is going to go through the three values, right? And so it's going to print out 192. It runs the indented code once for each of the values inside the tuple. And so in this respect, they're very much like lists. But they're also different than lists in some real valuable ways. Tuples are immutable. And so if you recall when we talked about lists, we compared them to strings because both lists and strings are a sequence of elements where the first one is 0, 1, 2, etc. But if we look at a string, for example, and we have a three-character string ABC, and we want to change the third character, y sub 2, to D, it complains and says, no, you can't do that. But you can do it on a list. So if we have a list 987, and we say x sub 2 is 6, which is the third item, then the third item changes from 7 to 6. Okay, so this is mutable. This is not mutable. And tuples are also not mutable. They are like strings. They're sort of like lists in terms of what they can store, but they're like strings in the fact that they can't be changed. So here we create a three-tuple, a three-item tuple, and we try to change the third thing from 3 to 0, and it says you can't do that. Not mutable. Okay, so it's kind of like lists in the kind of data that we store in them, and it's kind of like strings in that you can't change them once you create them. So this parenthesis, this constant, is the moment of creation. Once you've put the things in, you can't fiddle around with it. There's a bunch of other things you can't do with tuples. You think, why even use tuples? We'll get to that in a second. So here is a three-tuple with the numbers 3, 2, 1. You can't sort it because if you sorted it, that would change it. You can't add to it. You can't append the value 5 to the end of it because that would change it. And you can't reverse it. So none of these are allowed. Those are things you can do with lists, but you can't do with tuples. And you can read a documentation, but we can also use that built-in dir function, that really awesome dir function, where we make a list and we say, hey, Python, what will you let me do with lists? Well, you can append, count, extend, index, insert, sort, reverse, remove, pop. Lots of things. Now we make a tuple and say, hey, Python, what can we do with tuple? Well, you can do a count or an index, which means you can't do all these other things. So this is sort of a very much a reduction. Because everything you can do with tuples you can do with lists, but not everything you can do with lists you can do with tuples. So why? Why did I just waste all this time introducing tuples? All they are is have parentheses. What good are they? Well, it turns out that they're much more efficient because Python doesn't have to deal with the fact that we as programmers might change them. Python can make them quicker, they can use less memory, all kinds of things that save a lot of processing time in Python. So when would you use a tuple? Well, in particular, if you're going to create some list that you're never changing, we prefer to use tuples. And there's a lot of situations in programming where we create what we think of as a temporary variable. And if we're going to create it, use it and throw it away without ever modifying it, we prefer tuples in those kinds of situations. Okay, so we prefer tuples when we create things that are just temporary. It's the fact that they're temporary variables. They're like temporary lists because they're efficient. They're quick to make, and they're quick to get rid of, and they're quick to go through. Now, another really neat thing about Python that I really like is the fact that you can do sort of two assignments in one by putting a tuple on both the left and the right-hand side of the assignment statement. So if we think about an assignment statement, I like to think of it as having a direction that says these things go there. Well, in Python, you can actually send two things at the same time. The 4 goes into the x and the Fred goes into the y. This is a tuple. This is a tuple. You cannot have constants on this left-hand side. You can have variables or constants on or expressions on the right-hand side, but this must be two variables. Similarly, in this, the 99 goes into A and the 98 goes into B. Now, it turns out that you can syntactically eliminate the parentheses if you really want. And so this leads to a prettier syntax, I think. It's the exact same thing with or without parentheses, where we basically just say, hey, come back, A and B are assigned to the tuple 99, 98. So you can eliminate the parentheses as long as it's very clear what's going on in the tuple. And so this might be a little disquieting when you first see it, but it's just a tuple with no parentheses, and the 99 goes to the A and the 98 goes to the B. Now, it turns out we already did this. I sort of blew by this in the previous lecture in dictionaries because it allows us to go through the dictionary's keys and values with two iteration variables. And so if you remember, here's a dictionary. We put two items into it, and we can call d.items and get a list of tuples, a list of two tuples. Two tuples are a quick way of saying a tuple with two things in it. It's a two-element list that consists, each element is a two-tuple. And it's the key and the value, key and the value. And so if we just print this out, it's a list. So then when we put this on a for loop, it is a list, but the things inside the list are each a tuple. Each thing inside the list is a tuple. So when this iteration variable goes to there, it is like this tuple is being assigned into kv, which means the key goes into k and the value goes into v. The name I picked for k and v do not matter. It's just the first one and the second one. So k and v point here. Then the next time through the loop, k and v point here. And so that's how Chen 2, CSEV 2 and Chenwin 4 happen. And so this is really a tuple assignment, or a tuple iterating through a list of a tuple iteration variable, or a pair of iteration variables walking through the list. Okay. We don't do this a lot in this. It's really it's most heavily used for this situation where you're going through a dictionary and you want to see both the keys and the values, and then you use this method inside of dictionary called d.items. Another thing that's cool about tuples are that they're comparable. So less than, greater than, equals. And so they first compare the first leftmost thing. Then if that matches, they go to the second one, and then that one matches, they go to the third one. And so if we're asking, is 0, 1, 2 less than 5, 1, 2? And the answer is true. And it only looks at the 0 and the 5, and that's less than, so away we go. If we ask, is 0, 1, 2 million less than 0, 3, 4? Well, the 0 and 0 match, so it goes to the second one. 1 and 3, well, they don't match, and they're less than, so 1 is less than 3. So it's true, and it doesn't even look at these numbers because it doesn't have to, right? In this one, it doesn't look at those numbers. And now if we say, come here, is Jones Sally less than Jones Fred? Well, it compares this, they're equal, so then it has to look to the second one. Is Sally less than Fred? Well, no, because S is not less than F, and so that answer is false. Is Jones Sally greater than Adams? Sam, well, Jones is greater than Adams, so it never looks at these variables, and that turns out to be true. So these are comparable, which means we can use the less than or equal to, greater than or equal to, or not equal to. So we can use these operators on whole tuples. Now this turns out to be quite nice, because things that can be compared can also be sorted. Okay? So here is A, B, and C. A maps to 10, B maps to 1, C maps to 22. If I look at the items, I get back a list of 2 tuples, 3 2 tuples. They are not sorted because dictionaries aren't sorted. A maps to 10, C maps to 22, and B maps to 1. The order that these come out in is not something that we can control. But if we put these items into a variable, call it T, T is the list of tuples basically, and then we tell it to sort, it can do comparisons between all these, and it can sort them, and now they're sorted in key order, A, B, C. Now you'll never get any keys that match, so it never looks at the second one, right? Because there's one and only one key A, or B, or C. The value 10 never gets looked at. So this ends up sort by keys. Sort by keys. Okay, so this is a way to sort by keys. We take a dictionary, we get back a list of tuples, key value tuples, then we sort that sort that list of key value tuples, and then it's sorted by key. Okay, so that's one sort. There is a built-in function in Python called sorted, which takes as a parameter a list and gives you back a sorted version of that list. So we can collapse these operations by saying, oh, well, d sub items is this list of tuples, non-sorted, but sorted of d sub items is that same list of tuples, but then sorted. So immediately, in one step, we have A, B, and C properly sorted. And we can combine all this into one nice little for statement where we say for kv in sorted of d sub items. So this is now going to first sort the key value pairs by key, and then kv is going to run through them. So k is going to be A, 10, then k is going to be B, V is going to be 1, k is going to be C, B is going to be 22. So now we've printed these things out in alphabetical key order. Okay? So by adding sorted to d items, that means that this loop is going to run in key sorted order. Key sorted order. And that's because sorted takes a list and then returns, as it takes a list as unsorted list as input and returns a sorted list. Okay? Now, if we're doing something like our common problem of what's the most common word, what if we want to say what's the 5 most common words? In that case, we probably want to sort in descending order by the values, not the key. Okay? So we want to sort by the values instead of the key. So this is a situation where we're going to create a temporary variable. So here's how we're going to do it. Here is our dictionary with A10, and we want to sort now by the values. We want to, maybe see the most common or sort by the values. And so we're going to make a temporary list, and then we're going to loop through the items. So this is going to just loop through them, and it's going to loop through them in non-sorted order. And we're going to add, using the append operation, to this little list that we're making, but we're going to add a tuple that is value comma key. So if we make the value first and the key second in this tuple. So this syntax here of this parenthesis v comma k, that means make a 2-tuple with values from the v and k variable. And append a list. So you're going to end up with a list of 2 tuples. So if we take a look, when we're all done with this, each of these is a tuple. 10a gets appended, 22c gets appended, and it was simply the opposite order. The tuple, each of the tuples now has the value first and the key second. Value first, key second, value first, key second. So this is a bit of temporary data that we've created. This is a bit of temporary data that we've created. Then what we do is we call the sort method. Sort, take this list. Lists are mutable. The individual tuples can't be changed, but the order of the tuples can be changed because they are in a list. Temp.sort, and then we're going to say reverse equals true, so we sort from the highest down to the lowest. Okay? And now temp has been sorted, and now it is in a new order. 22, 10, 1 is what caused it to be sorted, so we know that the biggest value is 22, the key of C. Next biggest is 10 with a key of A, and the smallest is a value of 1 with a key of B. So the trick here is if we want to sort in some other way, we just construct a list where we put it in the order that we want it sorted, and this is more important now. The value is more important than the key. Now if we had another, like a 22F, it would sort first on the 22, and then it would sort the F1 after the C1, right? So we don't have any duplicates, but we could have this. We could have the key of C to 22, and we could have F also to 22. Okay, so take some time on this, get this one right. So now I want to show you a program that is going to show you the 10 most common words. We did a loop before where we did the most common word by doing a maximum loop at the end by looking through all of the counts in a dictionary and then picking the maximum. But what if you wanted the top 10? Right? That you don't want to write a loop for that. So we're going to use sorting. So here's what we're going to do. We're going to open a file. We're going to create a empty counts dictionary. Then we're going to write a for loop that reads each line, for line in F hand. Then I'm going to split each line into words based on the spaces using the dot split. Then I'm going to loop through each word in each line and use our histogram or dictionary pattern where I say count subword equals counts.get word comma 0. That basically says go look in counts. If the word key exists, give me back the value that's in that. Otherwise, give me 0. So this both creates the new entries and updates old entries all in one nice simple statement. So at the end of this bit of code right here, we are going to have counts with keyword word count pairs. Okay, so this is something we've done before. It's just dictionaries, reading, splitting, and then this pattern of how to accumulate in a dictionary. Then what we're going to do is we are going to make a new list called LST, and now we're doing this key value in the item, so this is going to go through the key value pairs in this list, which is the key value pairs from the dictionary, right? But then we are going to create this temporary list of tuples that are val comma key. So val is like 20 the, 14 hello. And that's what the list is going to look like, right? It's going to be tuples, but it's going to be the value and then the key rather than the key and the value. This one here is key value. This one here, LST, is value key. Now that we have a list that's value comma key, we are just going to sort it because now it's going to sort based on the first thing in that tuple, and we're going to reverse it so the biggest values are near the top. And so when we're all done, this is going to be a list, except it's going to be sorted based on the value. So that's just one step to sort it. So this is a good example of how we sort of go through some work. We get a data structure, a list, the way we want it, and now we can sort of leverage the built-in sort. We had to prepare a list so we could use the built-in sort. We could do this by hand, but it'd be very difficult. But it's easier to say, I think I'll make a list, and then I'll sort it. Okay, so I made two lists basically. I made the original one. Now I made this one just for the purpose of sorting. And now what I'm going to do to print out the top 10 is I am going to write a for loop, val key. Remember, this list, LST, is value key. And I'm going to say for val key in list, using list slicing, up, starting at 0, up to but not including 10, which is indeed the first 10 items. Now I'm going to print out key value, so it's going to be like, it's going to print out the 22, Fred 16, and it's only going to first print the first 10. So this list is in val key order, the tuples are val key order, and so I'm going to print it out in key val just so that I print out in a way that makes the most sense. And so this is a simple way to do a simple histogram of the occurrence of words in a file. So again, you should know this. You should know every line. You should know every line. Go back, review a couple times, but you should know the meaning of every line of this. And if you do, that's really good. So as you become more powerful and capable inside Python, you will realize that there are sometimes even shorter ways of doing things. Now, what I'm showing you here is not that different than what was on the previous page. It's just really dense, but you have to concentrate. So if I want you to understand what's on that previous page, if you don't understand this, don't feel bad. I'm going to explain it to you, but don't feel bad if you don't get it. Okay? So I'm just going to explain it. If it doesn't feel right to you, go back and look at the previous page. Okay, so here we go. I'm going to have a dictionary, and then I'm going to print in one line, sorted by value. So we'll start from the inside out. So this is a thing called list comprehension. It looks like a list constant because we start with square brackets. But this is a Python syntax that says construct dynamically a list of tuples v, k, and I would like you to loop through the items with k and v taking on the successive values. So this is creating that reversed list where value and key are the order of the items in each tuple, and it's going to do that. So this is going to expand. It's sort of like it goes, expands this. It makes a temporary list right now. Now, if you look on the previous slide, we called that thing LST. But here we don't even call it LST. And then once we have the list of tuples in value key order, then we simply take and pass that into sorted. This is a function call, the sorted function. And then, now I'm not reversing it, but the print statement prints out its ascending order of the value, 1, 10, 22. Okay, so this you can make these more dense once you're a little more comfortable with what's going on. It's sometimes easier to construct something that seems to have steps where you can put a debug print here, you can put a debug print here, you can do a debug print here, and you kind of see what's going on, right? Whereas once you really understand this, you can write some more dense Python. When you understand this, it's okay, right? So I'm not saying you're supposed to understand this, but I just want to point out that it's possible to do this in a tighter fashion. So tuples are like lists, except that you can't change them, right? You can't change lists, and you can compare them, you can sort them, you can sort lists of tuples. You can't sort within the tuple itself. The two values on the left-hand side of an assignment statement, we can use sorted, and we've played with sorting dictionaries by key and value. So that's kind of the end of this lecture, and so at this point I just want to kind of congratulate you on making it through the first 10 chapters of the book. So I'll drink a cup of tea to you. Here's your cup of tea. Here's my toast to you. In my Slytherin cup, and so it's time for a graduation ceremony. So I'll give a little graduation speech here with my graduation hat on, and this is my Slytherin wand. And so the reason I'm congratulating you at the end of this chapter is that at this point you kind of know all the fundamentals of programming. Programming really comes down to what's called algorithms and data structures. Sometimes we solve a problem by a clever series of steps that we put together, and sometimes we solve a problem by creating a clever data structure. And so the first few chapters were about algorithms, steps, loops, functions, very procedural, how you sort of create these threads of stepping and do things a bunch of times or skip around or whatever. And in the last 3 chapters that we've covered, we're talking about data structures. And programming power comes when you combine algorithms and data structures. Now in the next chapters, starting with chapter 11, regular expressions, we're going to learn sort of more clever ways of doing the same thing. So you kind of know how to do a lot of stuff now. From this point forward, you'll see, oh boy, that's more clever. Or we'll use a database. Oh, that's more clever. But it's not fundamentally different. And so that's why it's important for you to understand before you leave this moment, to understand everything that we've covered so far. Loops, functions, strings, files, tuples, lists, dictionaries. Because they're kind of the foundation, and everything else will just kind of be a subtle refinement / improvement. So once you understand that, you've kind of begun. You become a basic programmer, and I like poof, like I like magically Asperio you and turn you a Pythonio and something like that. Okay, enough of the Harry Potter reference. Thank you for spending all this time with me. If you've gotten this far, I really appreciate it. And of course, it's really just the beginning, but I hope that it has been a good beginning. Thank you.